All right, 11.6 volumes of pyramids. We're going to start off by reviewing a couple concepts here. This is find the area of the figure. Well, remember, we need this formula, area equals 1/2 apothem times the perimeter. Now, the perimeter is easy on this one because we already have one of the sides, and we see that it's a pentagon. So the perimeter is 6 times 5, or 30 centimeters. So that's easy. We already have this number, and we have the 1/2. We're just looking for the apothem. Now remember, the apothem is a very special line, okay? It goes to the middle of the side, right there. Now remember, it is a perpendicular bisector and an angle bisector. So first off, we need to find this central angle here. Well, it's 360 degrees in a triangle, and there's 5 sides. So if we do that, we get 72, which means the central angle here is 72. Since the apothem is a bisector, that makes each side 36. Now remember, I like to take this out and just do a little bit bigger, to have a little bit more room. So that's 36, that's 90. We know that if this is 6, that means each of these is 3. So here's a 3 right here. We're trying to find the apothem. All right, so from this angle, 36, that is the adjacent side. And we have the opposite side. So that means we're doing tangent. So tangent of 36 equals opposite over x. Now remember, in this case, when the x is on the bottom, we need to do the switcheroo. So x equals 3 divided by tangent of 36. And you just type that in your calculator. Okay? 3 divided by tangent of 36. So real quickly. And it's not going to work. Let's try it again. 3 divided by tan 36. And that gives us 4.13. Okay? So that's the number that goes up here, 4.13. That looks horrible, so let's fix that. 1, 3. Still not great, but you get the gist. All right, and if we take 4.13 times 12 times 30, we get area equals 61.95 square centimeters. All right, just a little bit of trigonometry review there. Now, moving on. Trying to find the volume of a pyramid. Well, the formula is simple. Okay, 1/3, the capital B means area of the base, and height is from the top of the pyramid down to the floor. So let's say, imagine you're like a treasure hunter and you crawled up the top of the pyramid and you put a little hole in the top and dropped a rope straight down to the middle of the pyramid. That's the height. Okay, now you notice over here, it could also be, if it's kind of a falling pyramid, the height goes from the top to where the base would be. All right? So let's find the volume of this pyramid. Well, what we have here on the bottom here is a right triangle, okay, with 4 and 6 as 2 of the legs, right? And we have a height of 9. So that's a straight up top. So first we have to find the area of the base of the triangle. So actually I'll just use the right terminology. Capital B is 1/2 base times height. All right? So that's 1/2, 4 times 6. So the area of the base is half of 4 is 2. That makes times 6 is 12. So that's the area of the floor of the pyramid. Now, volume of the pyramid, remember, is area of the base times the height divided by 3. Or 1/3 base height, doesn't matter. So we know the area of the base is 12. We know the height is 9, and then divide by 3. Well, we can do this in our head. 3 goes into 12 4 times. 4 times 9 is 36 cubic meters. Remember to put cubic because it is volume. It's the space inside. All right, originally Caffrey's pyramid had a height of about 144 meters and a volume of 2,218,800. Find the side length of the square base. So what that means is we have a square base and basically we have a pyramid that looks something like that. Now the height is 144 meters. Okay? We know that the area of the base is formed by a square. Okay? So volume equals area of the base times the height divided by 3. What do we know? Well, we know the volume. So we put that on this side. Equals area of the base, we don't know. We do know the height, which is 144. And we know the 3. Okay, so real quickly, we take 144 and divide by 3. That gives us 48. So we have 48B equals 2,218,800. To get B by itself, we're going to divide by 4. 48, sorry. Now remember, we're solving for B, capital B, which is the area of the base. So 2,218,800 divided by 48 is 46,225. Now remember, that equals the area of the base. But the area of the base is side squared because it is a square. So we just need to take the square root of this number. So we need the square root of 46,225. We get 215. So each side is 215 meters. So here's 215 and here's 215 all the way around. Pretty easy, just working backwards. Example 3. Okay. Well, we have a triangle. We need to find the area of the base first. Okay. 1/2 base times height. So we're just looking at this triangle right here. So here's the base of the triangle. Now it gets confusing because you have two heights. So sometimes it's easier just to come out like this and remind ourselves that first we're just dealing with the two-dimensional object. Okay. So 1/2, 4 times 3. So 3 times 4 is 12. Half of that is 6. So the area of the base is 6. Now the volume is the area of the base, which is 6, times the height divided by 3. Oh, I forgot to put the height in. We know that. The height is 14. Oh, no, sorry. We know the volume. My bad. We don't know the height. Sorry about that. We know this over here is 14 cubic feet. All right. So, just some simple math here. 6 divided by 3 is really 2. So that's 2h equals 14. Divide both sides by 4. The height is 7 feet. Simple enough. All right, just some knowledge here you need. Similar polygons are solids with a scale factor A to B. So the ratio of the perimeters is A to B. So if you have similar triangles or squares, the perimeter A to B. Ratio of the area is A squared to B squared, and volume is obviously cubed, so A cubed to B cubed. So let's see how that plays out. Pyramid A and pyramid B are similar. Okay, obviously pyramid B is a little bit smaller because the height is 6 compared to 8. Find the volume of pyramid B. We know that pyramid A is 96. Okay, so it's a very simple setup. First off, we're just going to make a fraction A to B. And the numbers we have, 8 and 6, which reduces to 4 and 3. We always want to work with reduced numbers if possible. Now, since we're talking about volume, we need to talk about A cubed over B cubed. So 4 cubed is 64, And B cubed, 3 cubed, is 27. Now, the volume that we have is on A, so that's going to go down here, 96, and we're trying to find the volume of B. So at this point, we're just going to cross multiply and divide. 96 times 27 divided by 64. And that equals 40.5 cubic meters. Again, all you do is type in 96 times 27 and divide by 64, and you get 40.5. So first you find the ratio of A to B, and if you're doing a cubic, it's A cubed over B cubed, and if you're doing area, you're doing A squared over B squared. And then you just cross multiply and divide. Pretty basic stuff. All right, last example. Find the volume of the composite solid. So first off, we need to find the volume of either shape. I'm going to do the cube first because that's the easiest. Okay, cube is right here. It's 6 by 6 by 6. So volume is length times width times height. Or in this case, 6 times 6 times 6, or just 6 cubed. So I'm going to put a little thing here for the cube. So 6 times 6 times 6 is 216. So the volume of the cube is 216, technically, cubic meters. Now, remember, volume of a pyramid is area of the base times the height divided by 3. So what is the area of the base? Well, it's a square, so 6 by 6, which is 36. The height is also 6 divided by 3. Really, we already know what this is. 6 times 6 times 6 is 216. 216 divided by 3 is 72. Again, meters cubed. And all we're going to do is actually add them together. 216 plus 72, and we get 288 meters cubed. And that's it.